Good morning. Welcome to another session on environmental impact assessment.
So we shall continue with Unit 3, Air Quality, Noise, Water Quality, Vegetation and Wildlife Impact. Course outcome, apply the knowledge of impact of infrastructure project on air quality, water quality, vegetation and wildlife. Learning outcomes, noise pollution and its impacts. Specific outcomes, definition of noise pollution, measurement of noise pollution and effects of noise pollution. So what is noise? A general definition of noise would be, unwanted sound, right? So that is a general definition of noise. So what is sound in scientific terms? Sound is a pressure oscillation in the air or water or any other medium which conducts and travels away from the source. So if noise can be controlled at the source, there will be saving in energy and energy cost, which will have an impact on production and production cost. So the intensity of noise can have a direct effect on biological and human communities. The intensity of a noise determines the distance over which it can be heard. The acceptability and therefore the impact of a new noise depends on existing noise levels. The period over which a noise is likely to occur is a factor which contributes to the impact of the noise. Noise during sleeping hours will have a major effect on the human community. Short periods of noise may have less effect than persistent noise. So this is a graph showing the sound, right, day or night sound in terms of decibels versus population density. So as the population density increases, you can see that the sound level also goes on increasing, right? So sound level increases when population density increases. So when the population is very low, you can see that the sound level is also very low. There is another diagram showing relationship between the sound in decibels on the x-axis with respect to different uh, different situations, like residential or industrial, commercial, freeway, right? That is freeway is like a highway, and airports. So you can see that uh, when that's night time in the residential areas, the sound level is about 50 to 60 decibels, right? Daytime it is about 52 to about 70 decibels. Industrial it is about 62 to 75 decibels. Commercial it can range from 58 to about 76 or 78 decibels, and highway is about 65 to 78 decibels, and airports you can see that it starts from 80 decibels and goes up to even about 95 to 100 decibels. So noise distracts, disturbs, and with sufficient exposure causes physiological effects leading to deafness. Annoyance results from interference with work, rest or sleep, or with individual communication or speech. Noise is in the workplace reduces productivity, efficiency, accuracy, and safety. The noise from industries is called industrial noise. From transport is called transportation noise, or ambient noise present in the neighborhood due to natural and other causes. Not all sounds at the same decibel levels are perceived to be equally loud, as the human ear is only sensitive. The human ear is less sensitive to some frequencies as others. Not all sounds at the same decibel levels are perceived to be equally loud, as the human ear is less sensitive to some frequencies as others, right? Meaning human ears cannot perceive sounds at low decibels, and it cannot perceive sounds at very high decibels. Beyond some limit we cannot hear those things, meaning we don't have the capacity to hear that. Our ears will become deaf and obviously will not hear. It goes below some decibels also, you will not be able to hear, like the bats, right? You cannot hear the sound made by the bats. Also, people perceive noise to be more intrusive the longer it persists, the more often it is heard, and the time of the day it is heard, right? So it is more, what do you say, affecting when it is persisting for a longer time and when it is often heard, right? And also it is also depends on the time of the day in which it is heard. A number of descriptors for noise have been developed to account for these factors. First one is equivalent sound level, the constant sound level, which in a given situation and time period conveys the same sound energy as does the actual time varying sound in the same period. The equivalent sound level is same as the average sound level. Perceived noise levels, a sound level in decibels by adjusting 113 octave band measured levels to correspond to subjective impression of noisiness. Effective perceived noise level, a measure to estimate noisiness of a particular sound. It is derived from instantaneous perceived noise level values by applying correction factors for pure tones and the duration of the noise. Sound exposure levels, the level of sound in decibels experienced at a given time period. Single event noise exposure levels, the level of sound in decibels experienced during a single event. For example, passage of an aircraft. Sound is mechanical energy from vibrating surface and is transmitted by a cycling series of compressions and rarefactions of the molecules of the materials through which it passes. The number of compressions and rarefactions of the air molecules in a unit of time is referred to as frequency. Frequency is expressed in hertz, which is same as the number of cycles per second. Humans can detect sound with frequencies ranging from about 16 to 20,000 hertz. Sometimes it is said as 20 to 20,000 hertz. Noise measurements are expressed by the term sound pressure level, which is a logarithmic ratio of the sound pressure to a reference pressure and is expressed as a dimensionless unit of power, the decibel. The reference level is 0.0002 millibars, the threshold of human hearing. So the formula for SPL is given below. So this is just a table showing the SPL for different activities, right? Starting from threshold of hearing to jet planes on the ground at 20 feet. So this is another chart showing some of the other activities, right? And at what decibels they can be heard. So noise measurement. So noise measurement unit is decibels, right? Calm environment is 30 to 50 decibels, and beyond 70 the sound becomes disruptive. The instrument that is used is called sound meter. The effects of noise on human beings, that is the ear of a healthy adult male responds to sound waves in the frequency range of 20 to 16,000 hertz. Young children and women often have the capacity to respond to frequencies up to 20,000 hertz. So the speech zone lies in the frequency range of 500 to 2000 hertz. So that's why I said that human beings can hear from 20 to 20,000 hertz. The ear is more sensitive in the frequency range of 2000 to 5000 hertz. Physiological responses, right? So what happens when you hear persistently to loud noise? A vascular response characteristic by peripheral vasoconstriction, changes in heart beat rate and blood pressure, various granular charges such as increased output of adrenaline evidenced by chemical changes in blood, slow deep breathing, a change in the electrical resistance of skin with changes in activity of the sweat glands, brief changes in skeleton muscle tension, right? So we come to the end of this session. Thank you.
Thus, we come to the end of this session. Thank you for your participation. Looking forward to meeting you in the next session.